For lesson 2 today, we're going to talk about opposites. So we're going to review the definition of integers first, but in a slightly different way than we saw it in lesson 1. Integers are whole numbers and their opposites. So what that means is all of the whole numbers, 0, 1, 2, 3, 4, 5, blah, 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 forever, and their opposites. So -1, -2, -3, -4, -5, and on and on and on. Okay? Let's talk about what opposite means. So in English class, or just in everyday life, the word opposite has a very specific meaning. So for example, opposite of outside would be inside. Opposite of agree would be disagree. Opposite of closed would be open. The opposite of down would be up. The opposite of weak might be strong. The opposite of same would be different. So all of these words have an exact opposite term. So integers also have an opposite. And it's just as simple as changing the sign, okay? So if you have -3, its opposite is 3. If you have 4, its opposite is -4. Okay? So a number and its opposite, fancy name here, ready? Additive inverse, add up to 0. 0 is known as the additive identity. This should sound familiar from when we used these words inverse and identity to talk about the multiplicative inverse or the reciprocal. So a number and its opposite add to 0. Why is 0 important? Because 0 is the number that does nothing, like identity stays the same, in addition and subtraction. Let's take a look here at exercise 2. So first up, we want to fill in the table. And then as we're filling in the table, we want to also plot and label the numbers on the number line. In this case, they are already actually labeled, so we don't really have to do anything extra there. All right, so the opposite of 5, it's positive, so make it negative. So -5. And then next up, a number that is 5 away from 2. So let's start at 2. So here would be 2. And now we want to go 5 away from that. I actually have 2 options here. I can go in either direction. 2, 3, 4, 5. So that could be 7. Or I could have gone the other way, but I chose not to. So for the next one, maybe we'll go in the other direction. Okay. A number that is neither positive nor negative. The only number that fits that description is right here in the center, the number 0. A number that is 3 away from -4. So let's go ahead and label -4. And now we want to go 3 away from that. I can go right or I can go left. This time, I'm going to go left. So 1, 2, 3. And so in that case, I got -7. Could have done the other direction if I wanted to. The opposite of -9. Let's highlight that. So the opposite of, and then the opposite of -9. So let's do that in 2 parts. First of all, what is in the yellow the opposite of -9? That would be 9. And then in the purple, the opposite of 9 would be -9 again. Notice that in this case, when we did 2 opposites, we got back to the number we started with. They're the same. So 2 opposites actually sort of cancels out and brings you back to where you were before. Okay? All right, and then let's label -9. And finally, the opposite of -6. It's negative, make it positive. So that's going to be 6. All right, moving on. Here is something that you should notice. Opposites are the same distance from 0, but in opposite directions. Let's explore that idea right now here in exercise 3. So we want to look at the following number and its opposite on the number line. And that number is -7. So I'm going to go ahead and I'm going to plot -7. Here it is. And then I'm going to plot its opposite, which would be 7. Okay? Now, our important fact is talking about the number 0. So I'm just going to mark 0 so that we have kind of a starting point here, okay? So now, how far would you say -7 is from 0? 1, 2, 3, 4, 5, 6, 7. Other direction, how far is 7 from 0? 1, 2, 3, 4, 5, 6, 7. So they are both a total distance of 7 away from 0. Now, the distance is the same, but what was different? If we want to go to +7, we have to go to the right. If we want to go to -7 from 0, we have to go to the left. So opposites are the same distance from 0, but in opposite directions. All right, next up, let's see what we can do with this number line to answer the following questions. What is the relationship between -7 and 0? We would just have to go 7 spaces. So you could say they are 7 spaces apart. Or they are separated by a distance of 7, something like that. Okay? Now, what is the relationship in number 2 between the opposite of -7 and 0? Well, I'll remind ourselves, the opposite of -7 we did up here was 7. So this is really asking, what is the relationship between 7 and 0? So between 7 and 0, there are again 7 spaces. So they are 7 spaces apart. Or they're separated by a distance of 7. Okay, now lastly, what is the relationship between the number 7 and its opposite? So we have 7 and its opposite. So we're comparing 7 and -7. So come back up here. With all of these, when we gave the relationships, we were talking about the distance apart. So how far is it actually from all the way here, all the way over to 7, is the real question that we want to answer. 7 plus 7, 14. So they are 14 spaces apart. Why does that 14 matter? Well, because the number we're talking about is 7, and if you double it, you get 14. All right, so just last up, our reflection question. Given any integer, how do you find its opposite?